All right, so in order to do something in standard position, I'm going to need three things from you guys, okay? So first thing is the direction. Which way are we traveling? Number two is the number of rotations, so how far we go. And the third thing is what quadrant do we finish in? So where does this angle finish? Okay, so these are the three things we have to make sure we have written down when we do standard position, okay? So for an example, number one, I got 565 degrees. So let's just make a quick coordinate plane right here. And we're always going to start on the positive side of the x-axis. So we'll always start here, okay? So because it's positive, right, 565 is a positive number, we are going to go up through our quadrants this way. So that tells me the direction, right? And if I go up all the way around and I go one time around, that's 360 degrees. Okay, so after I do a full circle, that's 360 degrees. Let's subtract 360 here. And when I'm done with this, I'll realize that I have 205 degrees left to go. Okay, so one full circle is 360. I still need 205. If I keep going and I do an extra half circle there, that'll be 180 degrees more. Okay, and one more quadrant after that would be 270 degrees. Remember, they always go up by 90s. So I'm at one full circle is 360. To get to 205 more, I have to go 180 more, and then an extra 25. But that's going to put me somewhere in this quadrant right here. So I'm going to put my terminal end right there, saying it's going to stop there, and this is in quadrant 3. And then I'm done with the standard position, because if we take a look at it, we've got our three things. First of all, we have direction, so I can see that we started and we moved up in a counterclockwise rotation. Number of rotations, it looks like one full rotation right here, and then a little bit more. And then it shows that I end in quadrant 3. Okay, we can try this on the negative side. So for example, negative 820 degrees. So if I'm going in a negative direction, I always start in the same place. But negative means I'm going to start by going down first instead of up. So if I go one full rotation, that would be 360 degrees in a negative direction. If I go another full rotation, so I go around again, that would be another 360 degrees. So that puts me at negative 720 degrees. Okay? So if I go around twice, that's negative 720 degrees, right? So when I combine these, I still need to go another 100 degrees in the negative direction. All right, so now let's kind of remember. I'm right here. One quadrant would be 90 degrees. And if I went again, another quadrant would be another 90 degrees. That would be negative 180 over here. So to go an extra negative 100 degrees, that would be negative 90. And I need 10 more to finish out that 100 degrees. So again, I'm going to land somewhere over here in this quadrant, and that is quadrant 3. Okay, so we can see everything again. It's direction. I can tell that I'm going in a negative direction because I started moving down. Okay, the number of rotations looks like 2. I went around this circle twice. And then I finished in what quadrant? I finished in quadrant number 3. Okay, now in rare circumstances, you guys might not finish in a quadrant. So the quadrants, this is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. Okay, so every once in a while you might end on an axis. So let's say you ended right there. Well, that's not in quadrant 2 and it's not in quadrant 3. So if this ever happens, you have to tell me where it lands. It's on the x-axis. Okay, and because it's on the left side, we'll call that the negative x-axis. So in a rare circumstance, you actually finish on the axis. If that's the case, you tell me exactly where it goes. Okay, all right, couple more times, couple more problems we'll go through. What happens if we are in radians? Okay. So for example, it is, let's do something like 27 pi over 4. Okay, so in this case, I really think it's helpful to write these as a mixed number. So 4 goes into 27 6 times, right? 4 times 6 is 24, and you had 3 pi over 4 left over. Okay, so this is going to help us out. 6 is not the number of rotations, so let's be careful with that. So if we're looking at radians, remember, an entire circle, we start here at 0 pi, and if I go around the circle once, a full circle will be 2 pi. Okay, so a full circle is 2 pi, half a circle is 1 pi, this is pi over 2, and this is 3 pi over 2. So what we're actually telling you is every quadrant from here to here is half a pi. Half a pi. If I go from half a pi to 1 pi, that's another half a pi. Okay, this is 1 pi to 3 halves pi, that's an extra half a pi. And from 3 pi over 2 all the way up to 2 pi, that's half a pi. That's 1, 2, 3, 4 halves. So 4 halves, which gives me 2 pi. Okay, just so you guys can see how that works. So you have to remember each quadrant is equal to pi over 2. Okay, kind of keep that in mind because that's going to help us figure out how we finish. So somehow I have to do 6 3/4 pi, right? So let's put that over here. Okay, so to get to 6 pi, let's work with the whole number first. It is positive, so we're moving in a positive direction. So if I go in a positive direction and I go around once, that's one full circle. That's 2 pi right there. If I go around again, one more full circle, that's another 2 pi. So that puts me at 4 pi. And if I go one more time all the way around, that will put me at 6 pi. Okay, so we actually have, we actually have 1, 2, 3 full rotations to get me to 6 pi. Okay, but now I've taken care of that 6 over here. Now I have to take care of that 3/4 pi, right? So 3/4 pi, if I wrote this as a decimal, it's 0.75 pi. Okay, each quadrant is only half a pi. So my question to you is 0.75 more than a half? And the answer is yes. So because it's more than a half, that means I'm going to break through one more quadrant. That would be half. That would be like 0.5 pi, but I want 0.75 pi. So I'm going to break off somewhere and finish in this quadrant, which would be quadrant 2. Okay. Another way to do this, because there's so many rotations, just so you guys can see it, if you just went and drew this once and you wrote times 3, to me that tells me you made 3 full rotations. Okay, 3 full rotations will put you at 6 pi, and then when you did the 3/4 pi over here, that would be a half, and then a little bit more to get us to 3/4 pi. Okay, so just another way of showing you guys a different way of doing it. All right, let's do one more. Okay, let's do something a little crazy. So let's do negative 70 pi over 3. Okay, so this is in radians, and we're going to write this as a mixed number. So how many times does 3 go into 70? Well, if we think about this, 3 times 20 would be 60, right? So we would go in 23 times, right? So 3 times 23, this gives me 69. So to get negative 70, I would need an extra 1 pi over 3. Okay, let's do it. It's negative. Negative means from our starting axis, I'm actually moving down. So if I move down once, that would be negative 2 pi. If I go around again, that would be negative 4 pi. Okay, so if you notice, every time I finish here, every time I go a full rotation, that's actually 2 pi. So if I go around, think about this, if I go around 11 times, 11 times, each rotation is 2 pi, that would put me at negative 22 pi. Okay? So I'm here after 11 full rotations at negative 22 pi. I actually want to get to negative 23 pi. So let's think about it. Each quadrant is half a pi. So if I move down here, that would be half a pi in the negative direction. If I move another quadrant over, this would be 1 pi. If I moved up one more, that would be 1.5 pi, or negative 3 pi over 2, right? So I'm at negative 22 pi after 11 full rotations. I need another one more pi to get me to negative 23. That would actually be half of a circle. So after I did half a circle right here, that would put me at negative 23 pi. Okay, so now I'm over on the left side of the x-axis. That gets me to negative 23 pi, and I have to go one more third. So 1/3 pi is technically 0.33 pi. And my question is that more or less than half a pi? And the answer is less. So I don't have enough to get into the next quadrant. It's going to finish somewhere in this quadrant right here, which is quadrant 2. Okay, so again, I have everything that I need. First of all, I have direction. I can see that I'm traveling down and in a clockwise position. I have the number of rotations. I had 11 full rotations. And then I know what quadrant I finished in. I finished in quadrant 2. So these are the 3 things that you guys need to do in order to do standard position.